Welcome back, children. I'm Srinivasan here. We are going to discuss exercise 1.2, first question. Before I request you, before going to this question, you want to watch concepts of functions video so that you can follow this better. First question, show that the function defined from r star to r star defined by f of x equal to 1 by x is 1 to 1 and on to, where r star is non-zero real numbers. Okay, this is second part of the question. First, let us see R star is a non-zero real number. It is the domain and the codomain. Let us see that R star to R star. The first question we will discuss in very detail. Second question on this we can move up. Domain, this is the input and this is a codomain. It's a collection of outputs and extra elements will be there. Now you see real number, non-zero real numbers. You have all the numbers here except 0 will not be there. That is called as a non-zero real number. So you have, for example, 1, 2, 3, 4 is there, minus 1, minus 2, minus 3, and decimal numbers, whatever, 2.5, 3.5. There between 1 and 2 itself, we have infinite numbers are there. Okay, all these numbers. The same is the case with your codomain. It's also non-zero real numbers. The same, whatever you have, because this is a very huge number set, right? All the numbers except imaginary numbers, all the numbers will be there in this real numbers. Okay, children. So you're going to map this domain to this codomain. Okay, that is what is explained here. I hope you have understood the question. The function given as f of x equal to 1 by x. Let us take the function f of x equals 1 by x. First part you have to show that it is 1 to 1. What is 1 to 1 function? One element should to map to one particular element. For example, if I take x as 2, f of 2, if I take where it should match 1 by 2, which is 0.5. So 2 should match to 0.5 here. Right, children? Likewise, whatever element you have. So we can understand that this is a huge number set. That is also a huge number set. Whatever number you are going to map, it will be there in the real number because it is a very huge number set. So all the numbers will be there. So every element will be 1 to 1. But you have to show how to show that. Take two images. Let us take two elements. First we will take x1, x2 belongs to that non-zero the domain. This is the input I am going to give. We are given with f of x1 equal to f of x2. We start with f of x1 to f of x. These f of x is the image. We know that f of x1 is the image of x1. F of x2 is the image of. So we are taking that images are equal. Then we have to check whether this images have an element in x, which means you have to reach x1 and x2. Then you can say that this element is an image of that particular element. It is 1 to 1. Let us start. The function is 1 by x. So this is 1 by x1 by 1 by x2. Take reciprocals and both sides. Taking reciprocals, what you will get? You know what I mean by reciprocal, right? Yes, x1 is equal to x2. So you started with f of x1, the images, and you got the elements are equal. So two different images and you started, but the two elements are same. X1 is equal to. So therefore, the function f is 1 to 1 function. Okay, children, the first part got over here. Now you have to show on to function. What do you mean by on to function? No element has to be left behind so that that element is not an image of particular element in x. Every element should have a inverse. In other words, or every element should be an image of a particular element in the domain. That is the actual meaning of that. Okay. Now we know whatever element you are going to choose, it will be an image of particular element because they are all huge numbers. All the numbers will be present here. So it is very clear it is onto. Okay, children, I hope you followed that. Now, how to prove that onto in the form of statements or the form of equations? We'll see that. Let us take the given question as y equal to 1 by x. Okay, children, f of x equal to 1 by x we are taking it. Now solve this for x. X is equal to 1 by y. Now you need to substitute this 1 by y in the function, given function. Substituting in f of x. Yes, you try. F of 1 by y is equal to 1 by the place of x, we need to substitute 1 by y, which is equal to y. So you got y. When you substitute, you solve for x and you substituted, you got y, which means it is an onto function. So it is the particular element is an image of an element in the x. So this is how you have to do. You take the question as y, solve it for x, and substitute. If you are getting y, then you can write that therefore the function f is onto function. That's it. So we have proved one to one and onto. Okay, right. The first part got over. Now let us move to the second part. If the domain is replaced with n, is this true? The previously it was non-zero real numbers. Now we are changing it to natural numbers. What are natural numbers? It starts from 1, 2, 3 to infinite, right? You don't have a negative number, you don't have decimals, you don't have any fractions or anything like that. Okay, children. Now R star. This is non-zero. You will not have 0. So 1, 2, 3 negative numbers, fractions, decimal numbers, square root. So whatever number you have, everything will be there in there. So from this you can understand whatever element you're going to take and define the function f of x, you will have that in your real number because it's a huge number set. If you take 2 and you substitute in the function 1 by x, you will get it. So clearly it is going to be an one-to-one function. You are right. It's going to be an one-to-one function. Now we are solving the second part of the question. Now we'll change the domain. I hope you would have understood the statement. Domain is n to the codomain is r star, non-zero. Now in this mapping where n is a natural set of natural numbers. Now you have to go with the same story. Take two elements from n belongs to n. Start f of x1 is equal to f of x2. You are taking two images here. Okay, so equal thing. So if you get the same elements, then you can say it is 1 to 1. 1 by x1 is equal to 1 by x2. Taking reciprocals, you get x1 equal to x2. Therefore, the function f is 1 to 1 or f of x is 1 to 1 function. The first part got over. The second part I am telling you, children, whatever you map you are there, but you check, you think of some numbers which do not be an image of this x. Say for example, 1 by 1.2 or 1 by 2.3. These numbers will be here, but it cannot be an image of any element in x because they are all natural numbers. 1 by 1.2 which is 10 by 12, which is 5 by 6. 6 if you divide, what you will get? 5 by 6. Yes, 0.42 43, 0.43. 0.43 will not be there in the natural number. So this 1 by 1.2 cannot be an image of any element in n. So it is left behind. If it is left behind, we have studied in the introduction itself, it cannot be onto. If you want to be onto, one-to-one onto function, you should not have any element left in the codomain. So here 1 by 1.2 is left. The same case is there with your 1 by 2.3. So there are huge numbers which do not be an image, which cannot be an image of the domain n. So you have to take any one example and we will explain. We see that 1 by 1.2 which belongs to the codomain cannot be an image of any element x belongs to yeah, any element. So it cannot be an image of any element x belongs. Therefore, the function f is not onto. Okay, children, this you have to write. You cannot directly take 1 by x1, 1 by x2 and you finish up like that. So these sort of questions you can explain like this. 1 by 1 you take one value which cannot be an image of any element xn which belongs to n. Therefore, it is not one-to-one. There are some elements left behind. So this is when you change a domain as natural number, it's going to be a one-to-one function, but it cannot be an onto function. It's not a onto function. This completes the question, children. Have any doubts? Please go to concepts of functions video. You'll get it clarified. That completes the solution. Thank you.